Hi, and welcome to College Algebra 1.7. Today we're going to do linear inequalities in one variable, and most importantly, talk about interval notation again. That was something that we kind of struggled with in our pre-chapter, so it's nice to hit on that. So, recall that interval notation, we use parentheses and brackets, and they are associated, parentheses with less than, greater than, and brackets when it's equal to. Remember, it's also when we're graphing, open circle is with no equal to, with no parentheses. The reason that is mathematically speaking, when the circle is closed in a graph, that means the endpoint is included in the subset, aka equal to and bracket. What I mean by included is if I were to plug 8 in for x, 8 is less than or equal to 8. That is a true statement. But here, if I look at the blue section there and I did 3 is less than 3, that's a false statement. So 3 doesn't actually get included in the answers. That's why it's an open circle there. Another interesting thing to note is if I were to graph these individually, just graph the left-hand side, for example, we get negative 2 is less than or equal to x, and if I were to graph the other side, x is less than 4, and I were to graph these, we would get an open circle to the left from that inequality and a closed circle to the right. Because these arrows run into each other, and also note that x is in the middle when everything is listed smallest to biggest, that I can write it as a compound inequality where it's all together and my interval is together. However, if I'm doing two separate ones that cannot be true at the same time, such as x is less than 2, so open circle to the left, which we have right here, and I'm sorry, 7 is less than or equal to x. If I were to line them up smallest to biggest, we see that x's are on the outsides. So we have to create two separate inequalities separated by the u for, as you remember, that means union, means both of these interval notations are correct. So solving linear inequalities works very similarly to solving a normal equal sign. For example, if I had something like this, I would, of course, minus 3x, which is what I would do over here. So 5x minus 3x is 2x. And I'd also probably want to add 7. Same thing over here works out. So we get 2x is greater than 16, whereas here I would get 2x equals 16, and I would naturally divide by 2, we'd get x equals 8. So over here, divide by 2, x is greater than 8, which as an interval notation, we would get 8 to infinity, because again, as we should recall, I always have my small to big when I'm talking about interval notation. So even though I have x listed first here, technically speaking, x is bigger than 8, so I get to infinity right there. Also remember that infinities always have parentheses. Now, something that can happen, as I highlighted right here, is if I get something to the effect of 3x is less than or equal to, sorry, negative 3x is less than or equal to 6. The first step, and only step, would be divide by negative 3. However, anytime you multiply or divide by a negative, you have to flip the sign. And we can actually prove that just by doing some test values. For example, a number that is really easy to say is bigger than negative 2 would be like 0. So if I plug 0 into the original equation, it should yield a true statement. Negative 3 times 0 would be 0. Is 0 less than or equal to 6? And that is true. So I know that this interval would hold. However, if I choose a number that is smaller than negative 2, let's say, for example, negative 3, and I plugged it into the original inequality. I get negative 3 times negative 3, which would be positive 9. Positive 9 is not less than or equal to 6, so I know that x cannot be less than negative 2, which is what you would have if you did not flip the inequality. So you have to flip the inequality when you multiply or divide by a negative. Okay. Absolute values. Oh, sorry, not absolute values. I apologize. That's excited. This is absolute values. We'll do this one first. So here we have a compound inequality. I like to solve these separately, where you just reuse the middle thing. So I would get negative 3 less than or equal to 6x minus 1, and 6x minus 1 less than 3. The nice thing about this is the steps are going to be the same, so I'm going to add 1 everywhere. So we get negative 2 less than or equal to 6x, 6x less than 4, divide by 6, divide by 6, divide by 6, divide by 6, negative 2/3 less than or equal, negative 2/6 less than or equal to x, which turns into negative 1/3 less than or equal to x. Here we would get x less than 4/6, or x is less than 2/3. Now, we should write them smallest to biggest. So negative 1/3 less than x, x is less than 2/3. Because a number can be true for both of these at the same time, we can write these as one inequality. More specifically, the x ends up in the middle. So when I go to write this, I would be bounded by these two numbers. So I only have one interval to worry about and write down. Now, on to absolute values. So if you remember from 1.6, if ever I had an absolute value that was such as x minus 5 equals 4, we wrote that as x minus 5 equals 4, normal, and then we did x minus 5 equals negative 4, where this value gets flipped. Now, the same process happens here. I get my normal inequality, and we also get a second inequality where the right side gets flipped. So I get x minus 5 and negative 2. The only big difference is the inequality gets flipped as well. So this whole thing gets flipped, which should make sense based on what we just talked about. I'm technically multiplying or dividing a side by a negative, so therefore the inequality has to be flipped as well. So from there, I get two problems to solve. But again, just like on the last slide, the steps follow the same. For example, here I'm going to add 5, add 5, add 5, add 5. So we get x is less than 7, and x is greater than 3. If I were to list these smallest to biggest, we'd get 3 less than x, and x is less than 7. Again, x is in the middle, so I can write this as a compound inequality, which means I only have one interval. I don't know why I put infinity there. Just autopilot brain. So that's how you would do 1.7. Thank you for listening, and I hope you have a great day.